Today's lesson is going to be talking about polygon angle sum theorems. But before we do that, we're going to talk about a few definitions we need to be familiar with. First of all, an equilateral polygon is a polygon with all sides congruent. We often see that in the equilateral triangle, but another one that we're very familiar with is the square. An equal angular polygon is a polygon that has all angles congruent. Now, normally when we have all sides congruent, we also have all angles congruent. But it is possible to have angles congruent and not sides, such as the rectangle. All the angles are 90 degrees, but the sides are not all the same. Now, if a shape is both equal angular and equilateral, meaning all its sides and all its angles are congruent, we call that a regular polygon. Again, the equilateral triangle and the square are two examples we're familiar with. The first theorem is called the polygon interior angle sum theorem. And this says that the sum of the measures of the interior angles of an n-gon of any polygon is n, the number of sides, minus 2 times 180. So, if we look at this example of a heptagon is a 7-sided figure. So you can see the one drawn on your screen. It has 7 angles. So what it's saying is if I add a plus b plus c plus d plus e plus f plus g, that would be the sum of the interior angles. If I add them all together and we look at our equation, the number of sides, which is 7, minus 2, which is 5, times 180 is 900 degrees. So if I add a plus b plus c plus d plus e plus f plus g, it's going to equal 900 degrees. Now, Corley, based off this theorem, said that the measures of each interior angle of a regular polygon is n minus 2 times 180 divided by n, or divided by the number of sides. And this should make sense. If the polygon is regular, meaning all the angles are the same, not in our example above, but one that actually all the angles are going to be equal, if I take the sum of the angles and divide it by the number of sides, which is going to be the same as the number of angles, it's going to tell me how much each angle is. So if we look at a regular heptagon, I know that 900 is the total for the interior angles based on the problem above. And that's the top of our equation. N minus 2 is 180, so 7 minus 2 times 180 all gives me 900. All over 7, which is the number of sides or the number of angles. So each angle in a regular heptagon is 128.6 degrees. Now we have a second theorem that deals with the exterior angles, or the angles outside the polygon. And it says that the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360 degrees. So again, you can see 1 plus 2 plus 3 plus 4 plus 5 plus 6 is all going to add up to 360 degrees. In a regular polygon, again, these would all be the same size. So I want you to try a couple examples. Give them a shot. If you're unfamiliar, you can look through my work and understand the problem better, or bring questions to class. But pause the video and try these 3 examples. So the first one, we're finding the measures of the interior angles of a nonagon. That's our formula, n minus 2 times 180. Well, we know there are 9 sides in a nonagon. So 9 minus 2 is 7, and 7 times 180. That means if I add all the angles up inside a nonagon, it's going to be 1,260 degrees. The second example says find the measure of an interior angle of a regular pentagon. Well, a pentagon has 5 sides, so we're going to set up our equation, 5 minus 2 times 180. So we get 540 degrees for the total angles divided by 5, divided by the number of sides or angles. So each angle in a regular pentagon is 108 degrees. And lastly, find the value of x. Well, x is in the exterior angles. So we know if we add up all 5 exterior angles, they're going to equal 360 degrees. So we have the first angle, x plus 2x plus x minus 1 plus x plus 6 plus 90. All has to equal 360. Combine like terms. We get 5x plus 95 equals 360. So 5x is 265 and x is 53. So we would know how big each of those angles are based on what x is. And that's it. I hope you had a good learning experience, and we will see you in class.